Hey guys, welcome to my channel. So on this channel, I'll be starting to teach you like chemistry for the HSC boards. Uh, so I hope you like these videos. Please share, comment, and subscribe to my channel. Today I'll be starting with the first chapter: alcohol, phenol, and ether. So in this chapter, we are first going to talk about alcohol. So first I will do some reactions associated with alcohol. So first we will do some reactions. Like first we will see this chart. So when you have alcohol, you can prepare alcohol from alkene, and then alcohol to aldehyde or ketone, and then aldehyde or ketone to the carboxylic acid. How do you do this? You go from here to here, oxidation, and in the reverse you do it. You do the reduction. So if you want to use, like suppose if you use alcohol plus mild oxidizing agent. So alcohol plus mild oxidizing agent, basically you are going this side. So it will give you aldehyde or ketone. But on the same alcohol, if you use strong oxidizing agent, then you will get the carboxylic acid. So alcohol plus mild oxidizing agent like CrO3 or PCC. So these are two examples of mild oxidizing agents. This will give you aldehyde or ketone. So from this primary alcohol, you will get aldehyde. Similarly, from secondary alcohol, you will get ketone. So this is a method to remember that from primary, you will get aldehyde. Secondary alcohol will give you ketone. And then you can say that alcohol plus strong oxidizing agent, uh, which you can give example of like this KMNO4 and K2Cr2O7 HNO3. So these are what strong oxidizing agent. So this will give you, from alcohol we will jump directly to the carboxylic acid, right? Then in a similar manner, if we see reaction of alcohol, so this is known as oxidation by catalysis. So when you have alcohol, use copper for 573 Kelvin, it will give you aldehyde or ketone. So this is known as the catalyst, the copper. Okay. And then the primary alcohol will give you aldehyde, secondary alcohol will give you ketone. So this is the same, like on the similar lines as this one. So this is a trick to remember that. And then from like tertiary alcohol, if you use same copper at 573 Kelvin, it will dehydrate alcohol to form alkene. Then alcohol to alkyl halide. I meant to say alkyl halide, ALKYL, alkyl halide. So alkyl halide is basically CH3Cl, methyl. So it is basically like uh, a chloromethane. And so what you will do is that you will use alcohol plus PCl5. So that will give you RCl, which is basically alkyl halide. So a trick to remember this reaction is that you can write ROH like this in expanded form. Then you can write PCl5, where PCl3 is in the center, and then Cl and Cl attach on the either side. So this will basically form PCl5. This thing is basically PCl5, and this is basically ROH, alcohol. So you can break it, you can break the bonds like this, and then this side will give you RCl, alkyl halide. This will give you PClO3, and this will give you HCl, as I have written over here: HCl, RCl, and PClO3. So moving on to the next reaction, you have alcohol, and if you put red phosphorus to it, you will get alkyl halide. Similarly, if you have ROH, and if you add ZnCl2 plus HCl, so this ZnCl2 and HCl is basically called as the Lucas reagent. So this Lucas reagent, uh, this adds with the help of Marconi-Cove's rule, Marconi-Cove's addition rule. Okay, so you will get alkyl halide. Similarly, if you use ROH, alcohol, and if you add chlorine, so that will give alkyl halide. So that's it for today's video. In the next video, I will show you how we can like prepare alcohol. Uh, so in that one, like I'll just give you a brief idea of what I'm going to teach. This aldehyde, I'm going to use a reducing agent to convert it to alcohol. Similarly, I will use a reducing agent to convert the carboxylic acid into alcohol. So as you might have guessed that I will use a strong oxidizing agent for carboxylic acid and a weak oxidizing agent for aldehyde or ketone to convert it into alcohol. And similarly for alkane or alkene, I will use oxidizing agent to convert it into alcohol. So that's it for today's video. Thank you and keep studying. Bye bye.